So this session was about building a scalable infrastructure for web hosting companies, and in this session we're actually laying bare all of our secrets and lessons that we've learned in terms of running a web hosting company ourselves and learning large-scale web hosting infrastructure for the last 12 years. Some of the key takeaways are completely automated deployment. All of our thousands of servers, every time we add a new server, a new rack, all of the deployment sort of happens automatically. Any particular box sort of automated scripts run and install cPanel Linux and configure all these sort of configuration parameters and monitoring and metrics, etc. on that system in a completely automated fashion. I covered some of the tools that we've built internally to monitor these systems. We measure actually hundreds of metrics across CPU, disk, network, memory, etc. on every one of our systems, and sort of what metrics we collect, what are the tools that we use. For instance, some of the tools that we use are Ganglia, Graphite, Nagios, etc. One of the other key important aspects, I think one of the most fundamental aspects of running a hosting company is the kind of code and scripts that you write to ensure that it's a multi-tenancy system, so there are thousands of hosting customers on a single machine, and the kind of code that you write and the kind of scripts that you write to ensure that every customer is getting a fair share of the system and can burst to a higher capacity whenever required, such that no customer is abusively using the system at the cost of a detriment or lack of or a poor service to other customers that are on the system. So I actually discuss a lot of the interesting resource limits that we've put into place to ensure that that every customer on a shared hosting system gets fair share of resources. It's a very interesting presentation. It's compiled amongst a bunch of tech folks at Directi, and in some sense we're literally sharing with you. So I'm going to try and keep this a little bit low tech to a certain extent. I know there's a mixed audience out here. But anybody who's sort of running a web hosting company or building scalable web infrastructure for hosting, etc. So give you a perspective on. I'm going to be sharing with you, in some sense, trade secrets, but in some sense, pretty much everything that we've learned in building scalable hosting infrastructure for our shared hosting platforms and our hosting platforms for all of our customers. And so anybody who's sort of running a web hosting business, anybody who wants to build out a web hosting business, anybody who wants to set up your own servers and scale them, and what are the activities and aspects you need to take care of while building a scalable hosting infrastructure at the back end. And I'll take you through networking, deployment. So I'll also give you an idea of the kind of practices, best practices that we follow, lessons that we've learned, automation that we've put into place, tools that we've built internally to facilitate our hosting infrastructure. So in some sense, it sort of also serves as a partial sales pitch, I guess, along with revealing our secrets. But you get a sense of sort of what works, what kind of stuff goes on behind the scenes, right? So let me start off. The agenda sort of comprises of, as I said, infrastructure, inventory management, deployment, resource limits, security metrics, and support tools. And I'll run through each of these sections, starting off with sort of infrastructure. So I'll give you guys an idea in this section about the kind of backend infrastructure that we have that's running all of our shared hosting environment. This is sort of the network diagram of any one of our hosting facilities. We have hosting facilities in 4 to 5 different locations across the world. And so it comprises of sort of connectivity from the internet. And you'll see dual redundancy at every step, starting off with right from sort of our edge routers. That's the sort of first 2 cylinders that you see in the diagram, which then connect subsequently to 2 aggregation switches. Aggregation switches are sort of the border switches which individually then connect to various racks that we have. And that's what you see at sort of the bottom end, n number of different racks. And then each rack hosts all of our hosting servers. And that's exactly, that's actually a picture from one of our data center. That's actually what one of our racks looks like, shiny little blue lights, the front and the back of a typical rack that's actually hosting. Some of the sites that you guys host with us today are on servers that are on one of those racks. So that's basically what our layout looks like at the data center. We also have DDoS mitigation capabilities at every one of our data centers. And as any large provider, if you actually, VeriSign could actually talk a lot about this, but actually see consistently year after year, the kind of DDoS attacks that you face on the internet have become more and more sophisticated, and the bandwidth requirements in terms, or the sort of the bandwidth that they end up consuming, etc., it's become more and more intensive. Statistically, I can tell you, by the way, that in any given week, at any point in time, if I look at the entire Directi infrastructure across all of our shared hosting and Skenzo and Media.net servers and Talk.to and all the business that we run, at any given point in time, in any given week, we at least face 2 attacks, 2 DDoS attacks. Most of you and pretty much all of you who use our services will never really realize this because our mitigation team, our mitigation equipment, and our strategies will literally take care of all of this stuff. But we have employed, and we've learned hard lessons sometimes, with downtimes, etc. But over time, we've built out mitigation processes and technology and tools, both ourselves and along with partners, that will ensure that that you guys will never face a downtime. And so, just a typical DDoS mitigation system, the way it works is, at every one of our facilities, we actually capture what's called flow data from our routers. That's sent to DDoS mitigation equipment run by a DDoS mitigation service provider. And then based on, so typically how DDoS mitigation service providers work, or any DDoS mitigation equipment works, is that it will analyze your traffic as a baseline. So when stuff is all hunky-dory and there's nobody attacking you, it performs an analysis and defines that as your baseline. And then suddenly when there's any attack pattern, and there's a detection of any attack pattern, so if there's a botnet or some sort of a DDoS attack, automatically it detects that there's a change in the pattern of the traffic. It then takes that segment. So in any given data center, we have thousands of IP addresses and hundreds of servers. It'll take that segment of the traffic that's currently under attack. It reroutes it through what's called a scrubbing and cleaning service. So there's equipment that will scrub and clean that traffic. So it reroutes that attack portion of the traffic through that scrubber and cleaner, which will then clean up that traffic, remove all the attack traffic, send the legitimate traffic back to the actual servers, and then it gets served from our infrastructure. So every one of our data centers will have, have the exact same deployment in terms of DDoS mitigation. If you look at our network layout, again, every data center, every facility, we have multi-home connections. So 10 gig links, 10 gig fibers running from various different providers. We announce our prefixes, what's called, so we have sets of IP addresses. We announce all of our IP addresses on all of these links. So if any of the link goes down, traffic can still be routed through any of our other links at any point in time. As I said, we use sort of N+1 redundancy at every step, dual redundancy at every step in a sort of active-active or active-passive manner. So we'd have 2 independent routers. We buy some of the best equipment that's out there. All our routers are Juniper. All our machines are Dell, and we buy some of the best, all our switching infrastructure is also Juniper. So 2 independent routers running what's called VRRP, which essentially ensures that if, again, VRRP is a protocol used to ensure that if there's any downtime or outage of a router, routers typically don't fail, by the way. I might have seen in my entire history probably 2 instances where a router failed in the last 12 years of being in this industry. But if they do, we still sort of got you covered because we have sort of redundancy at that level. Then we have 2 aggregation switches, and then the entire set of racks that we run, all the switches combined together form what's called one virtual chassis. It's a feature of the switch, and by virtue of that, again, the entire, even though we have so many different servers, so many different ports, so many different switches, they can all be managed as one aggregate unit as far as the interface is concerned and as far as management, etc. is concerned. On each rack, wherever we're putting your hosting servers, on every one of these racks, we have 2 switches. On every one of the servers, we have 2 cards, 2 NIC cards that connect to these switches. We always segregate primary traffic from management and backup traffic, which means every server contains 2 links. One link is used for all your primary public-facing, actual live website traffic, and the other link is actually used for all the backend management using an IPsec secure tunnel, all the backend management and all the backup traffic. So none of that stuff can ever impact the primary production interface. And if for whatever reason your primary production interface is down, you can still access the server and figure out why it is down through the secondary management interface with an independent set of IPs through an independent channel, right? So that's the way we operate every one of our servers in these racks. Each server has 2 power units. Each rack has 2 completely different power strips, so every server is getting power from 2 completely different power strips. Both those power strips are connected to 2 completely different UPS banks, so at any point in time, there is no point of failure. If one of the power units fails, or one of the power strip fails, or one of the power sources fails, the server still continues to function because it's completely sort of dual redundancy. And I already mentioned 2 NIC cards per server for every one of these servers. We have data centers in Austin, now even San Francisco, UK, India, and we're sort of setting up Germany and Turkey pretty soon. And sort of identical setups at each of these locations, right? So once you mastered the art, you just sort of replicate the whole process in each and every one of these locations. So that's as far as our backend server and data center infrastructure is concerned and stuff. And I'm sort of covering in some sense, by the way, a superficial sliver of everything that goes on behind the scenes, just to give you guys a flavor of what it takes to run a scalable web hosting infrastructure and operation. The next is inventory management. We buy hundreds of servers, thousands of spare parts, so many different racks to manage at so many different geographical locations. There's stuff always shipping around. There's always, at any given point in time, again, you'll realize this, when you get to beyond a certain point, beyond a couple of thousand servers, you can pretty much expect that every single day some part is failing somewhere. If you look at like a mean failure rate of roughly about once a year for anything like a hard disk or a RAM chip, maybe once in X years, etc. The moment you get to 365 servers, you can expect one hard disk to fail every day. So when you're at thousands, you're expecting at least X number of parts that are going to constantly fail on a continuous basis, etc. So there's a management system that's required to manage all this inventory, and we've sort of created an internal team sort of built out our entire inventory management system on a Ruby on Rails project. Which sort of tracks all of our inventory. So, I don't know if you guys can see or read any of this, but it tracks all of our, racks, devices, spare parts, applications, configurations, and there's a bunch of reports and utilities that are provided. So, for instance, this screen is one cabinet. This page represents one cabinet. It talks about sort of what kind of power wattage is there. You go one step further, and you actually get to the actual layout of the rack inside the application. Shows which all servers are there inside that rack. That's sort of the 42U rack showing sort of, each individual server in there, what kind of a server is there, which inventory, what number, from where it has come, what stock, and so on and so forth. And then, from here we can manage those servers, perform certain functions on them. And then we sort of also track each server, whether that server has spare parts or not, and all that stuff is sort of tracked inside this nice little interface that our team has built, sort of a homegrown interface. This is also what we use to sort of manage our deployments, etc. And then, then per device, there are sort of access links for DRACs. All of our licensing also gets managed through this interface. So all the software that we buy, procure, and install on every one of these boxes, we need to manage the licenses, track the licenses, etc. And that happens through this inventory management interface, right? Now, again, at this scale, we can't afford to use people for everything, both because of costs, and more importantly, as opposed to costs, because of sort of preventing human error. We can't sort of perform all these kinds of upgrades or deployments. Every time we put in a server, we can't have all the steps being carried out manually because, hey, what if you miss one of those steps? So all of our deployments are completely automated. They're initiated from the inventory management system that you saw. So, if you need to dump a new hosting server right now, firstly, one of the other interesting things, and it's again, if you read about this on the internet, you'll figure out, you'll realize that most downtimes invariably are caused by human intervention or human failure or whenever a human is involved in the equation, the probability of downtimes increase, right? And one of the philosophies that we follow, and it's a standard philosophy that a lot of people, a lot of data centers, a lot of large companies that scale infrastructure follow, is that once you've set up a rack, you dumped all the servers, connected them, wired them all together, nobody touches the rack. We actually think of, all of our deployments are thought of in units of racks. And so nobody ever wants to go out there and put another machine or change something in the machine. We pre-design the entire rack as a unit with all the wiring, all the equipment, plonk it in there, and then nobody should touch the rack unless there's really a catastrophe. In fact, in most circumstances, the ideal way to handle downtimes is if there's something wrong with a machine or a rack or any piece of equipment, we move stuff out, virtually. We run stuff on another parallel, say, secondary machine that's available, etc. But the replacement of spare parts or replacement of machine, etc. never takes place in line, in time, at the time of a catastrophe or at the time of an issue. We don't want to go out there, and that's the other problem, right? Whenever there's a problem, if you try to manually fix the problem while it's taking place, again, there's a higher probability that you'll botch something up and create a bigger problem. So we always try and maintain redundancy in terms of trying to make sure that we don't have to touch the infrastructure or touch the hardware or touch any of that stuff once it's fully set up. So our deployment boxes, it's as simple as, one of the boxes in the rack, we just change its profile from the inventory management system to a hosting box, let's say a Linux hosting box. We use a tool called Cobbler, so that's what gets triggered in the background at Cobbler and Puppet. Puppet's for config management. And so from the time we change the profile of the box to a hosting box, it takes about 1.5 hours of the various scripts that run one after the other to set up that entire box in terms of everything that's required for it to become a full-fledged hosting server with all of our tools, resources, agents, monitoring agents, latest updates, patches, and everything. And so first step would be that Cobbler will install Linux on that particular box and run a bunch of first boot scripts like installing cPanel, adding the relevant DNS records, configuring WHM and the settings of WHM on that particular box. Then we've written test suites. So not only have we written scripts that actually install all the stuff that's required on that box step by step, at the end of that installation process, there'll be a suite of tests that will go back and check every one of the installation steps and figure out if this needed to be configured, is it configured correctly, all the parameters correct, etc. And add all the functional monitoring checks. We use Nagios, Graphite, Ganglia, and OpenTSDB. These are 4 fairly common tools in the infrastructure management space to monitor and monitor metrics and alert and generate alert and escalations, etc. for downtimes and manage functionality checks on various services. All these checks are added automatically. So if a particular server contains, let's say, 7 to 10 services, like there's Apache, there's FTP server, there's SSH, there is MySQL, so on and so forth, automatic functionality checks will be added for every one of these services at the time of install and deployment. Then we also have agents that collect hundreds of different metrics, and I'll show you a screenshot of some of those graphs, etc. But pretty much everything, so the standard resource on a server, CPU, disk, memory, etc. For every one of them, we collect granular parameters on intervals of maybe 10 seconds to 1 minute, and all of these are plotted in various graphs that are available for viewing, as well as every one of them gets linked into our monitoring and alerting system, where if, for instance, CPU goes above a certain threshold, or memory falls below a certain threshold, or disk usage goes above a certain threshold, every one of these will generate escalations. There are escalation rules that are configured that will ensure, based on the severity, it's either a information message or a warning message or a critical alert. Each of those types of alerts then have sort of various escalation policies in terms of coming all the way right up to me or senior management in the system administration team or the NOC, 24/7 NOC that's looking at these alerts on a constant basis, right? So all of this stuff is configured through automated scripts using Cobbler and using Puppet. So Puppet actually handles configuration management, application versions, configurations of things like Bind, which is your DNS server on that box, or Exim, which is which is for emails, etc., or Ganglia, which is for our metrics monitoring, or Nagios, which is for our alerting and escalations. So all of these configuration files and configurations are what we call internally as Puppetized, and so they exist in Puppet. And then when Cobbler finishes its work and sort of Puppet starts configuring all of this stuff on that particular box that we sort of want to make live, right? So in about an hour and a half, all these steps are completed, and that sort of finishes, that sort of covers our automated deployment part. But again, if anybody's setting up a large-scale infrastructure, or even when you're scaling to sort of tens of servers or hundreds of servers at any point in time, spend and invest time in trying to completely automate your deployment processes, all the repeatable processes, because like I said, some of the worst downtimes result because somebody missed some step somewhere in configuration, did not put in an appropriate resource limit, resulting in people being able to abuse the system, or somebody missed out on some step and some service didn't come up, or things like that, right? And there's so many hundreds of checks, hundreds of variables, etc. involved that you can't really do this manually for each server that you deploy. I come to sort of the meaty part of really running a web hosting company, and a lot of people who bought VPSs and who bought dedicated servers and installed cPanel or Plesk or whatever and try to start sell hosting to your customers. One of the first fundamental principles of running a hosting company you have to realize is that it's a shared multi-tenancy system, which basically means that if you're dumping 1,000 customers' accounts on one server, there are 1,000 customers who are going to share that server. And invariably, by virtue of that, you will have either rogue customers or customers whose code doesn't function perfectly or customers who have vulnerabilities, etc. In a shared system, your biggest risk at any point in time is resource constraints because of abuse. So most hosting providers invariably face problems in this particular area. In fact, the funny thing is that this is one area which has not been productified to the extent that it should have been, because shared hosting has been around for more than a decade now. The fact is, every company who sets up a server and puts up a bunch of websites on it eventually realizes the biggest problem that they face is suddenly some customer's load shoots up, or somebody else's load shoots up, or somebody's database queries end up taking too many disk IOPS. There are so many resources that people have access to in a shared hosting system that will result in a scenario where 5 customers, you might have 1,000 customers. By the way, a single box, if nobody abuses today's machines, if none of your customers abuse any of your parameters, a single box is probably adequate to host 5,000, maybe even 8 to 10,000 websites when adequately configured, right? None of us do that. We also sort of stay significantly below that limit. But really the problem occurs not with the thousands of customers that you're hosting, but the 10 customers out of that 5,000 or 20 customers out of that 5,000. And these 10 and 20 can keep changing during you running your hosting business. That end up abusing the system, and not necessarily because they want to abuse it either, just because either their code was poorly written or they suddenly got a large number of a large DDoS attack or whatever, or different things that happened where stuff wasn't configured properly. And by virtue of those 10, 20, 50, customers utilizing all the resources of your system, the remaining 980 customers are not getting CPU or not getting memory or not getting network I/O, network throughput, etc., because it's being abused by a small set. The biggest rocket science or the biggest IP in some sense in running a hosting business is how well you understand the resources of a system and how well do you create a cage or a box that will ensure that every one of your customer gets a fair share of the system. At the end of the day, by the way, I mean, it's a common myth, right? All of us as hosting providers always have this, funda of selling unlimited packages, but really there's nothing like an unlimited package. Every package has limits. Everybody knows that, right? And it's all these packages are sitting on a box, so it's not just that you're limited by the size of the box, but you're also limited by the fact that you're sharing these resources with thousands of other customers, and that's the known truth. And so, the best hosting providers with the best uptimes will actually have done maximum amount of research and spend maximum amount of time in how they configure their resource limits. And resource limits are a science, literally. There's so many variables in we took months and months of configuration and years of research and knowledge that we've gained over time to actually get this stuff right, to get it to a point where we know everything works. But there's so many variables. The resource limits on a box of a certain size will be very different from, let's say, if I have a 16-core machine or an 8-core machine, I might have differences in the way I configure them, right? Each variable, so you want to make sure that when you constrain people, and that's why I made the statement that I made before. On a shared hosting environment, you want to make sure of 2 things. One is that everybody's getting a fair and equitable distribution of resources. So there's no point in time when a customer is being unfairly penalized because of some other customer or so on and so forth. And the second thing you also want to make available, you want to make sure is that customers can burst, because nobody's load is going to be a flat line. So there'll be a situation where some customers' load peaks in the morning, somebody else's load peaks in the evening, somebody else's load peaks in the night time. Different customers will have different times when they burst. So somebody will suddenly get 10,000 hits, but then the rest of the day they're not getting any hits. Does not mean when they get those 10,000 hits, you suddenly block them, because now they're utilizing a large chunk of that server, right? So you want to make sure that customers can burst for a reasonable period of time. You want to make sure everybody's getting fair and equitable sharing of resources. It's a fairly complex, art. There are significant number of really smart people in Directi and Reseller Club have spent quite some time on in terms of working towards this to try and make sure that when you host or when your customers host websites with us, that everybody's getting a fair share of their resources and everybody's getting what they deserve, and nobody can result in creating a downtime for somebody else who's hosted on that same system. So I'll run through resource limits. I've sort of covered this part. There are many. So less than 1% of customers on a system will typically end up being the primary reason why your other customers are seeing either a slow website or lack of resources or any issues, etc. It's always less than, it's a very small fraction. And that's the reason why you want to make sure that you can sort of structure this resource limit stuff properly, right? So essentially at the end of the day, in hindsight, you can sort of start treating this in a very obvious manner. There's a lot of complex code that goes behind all of this. But really, a physical box comprises of CPU, disk, memory, and network bandwidth. That's really it. These are the 4 resources that you have available. And you want to make sure that every single customer that's hosted on that box does not abuse beyond a certain point in time every one of these 4 parameters. So I'll cover these and a couple of other aspects and resource limits. So for instance, in CPU, we try and make sure that the maximum burst allowed to a user is 30% of an entire server. So despite the fact that technically the user is, I'll give you a hypothetical example. Let's say on one server we're putting 1,000 websites. I'm not dealing with exact numbers out here, but as an example, technically each client should get 1,000th of the resources. But that's not the way you would do this, because otherwise nobody will be actually able to, serve their website. So for instance, we allow a max burst up to 30% of the entire capacity of the machine for a single site for a certain period of time, because we know that not that everybody, all websites on that machine are not going to try and burst to 30% at the exact same time. And so because of that, so I mean, again, these are numbers that we've sort of worked on for a long time, and taken sort of historical measures and trends, trying to make sure that nobody ever gets unfairly penalized, but at the same time we have adequate resources available to ensure everybody gets sort of a fair resource in the system. And what we also do is, in Linux or in Unix operating systems, you have, I mean, same in Windows, you have something called process priority. So any process that we find that's abusing the system, meaning going beyond our limits, we basically in Linux we call it nice, right? There's a command called nice that will allow you to change and modify the priority of the process. So we're not knocking it off or blocking it, but what we're doing is we're reducing its priority, saying that look, you got your fair share. Now if you reduce your priority, somebody else is going to get their stuff done, and after their stuff is done, if CPU capacity is still available, you'll get to burst even beyond the limit that we've set. So that's done by what's called nicing processes, right? So we, typically about 0.15% of the time processes get 0.15% of the processes get niced about 100 times a day in this system automatically. So the script's running that's sort of taking care of this on a continuous basis in terms of CPU resource limits. So the next resource that we deal with is memory, where we again make sure in a shared hosting environment there are so many different processes. There's CGI processes, there's cron scheduled tasks that people run, fast CGI and PHP processes, etc. And for each of these, we've spent, again, time and effort in determining, typically, if you develop an application, what's the kind of memory consumption that a single run of that particular application as a cron job or as a PHP script should take, figured out, what's the max limit that we should, put for each of these, etc., and we sort of limit the maximum memory that each of these processes are allowed, beyond which they cannot access memory. Again, 100% of well-written code will always work in this environment, but somebody who's got a memory leak in their code, where their code is running for hours and hours and creating lots of objects but not releasing any memory, they will get to a certain point beyond which their process will not be able to access any memory and will get an out-of-memory exception. So if any of the customers have written any bad code, it'll basically get blocked out here and therefore not end up impacting or affecting the other customers on the system. Then there's process count. Again, on any shared hosting environment, there's a lot of spawning of processes, and sometimes, again, bad code or errors or vulnerabilities can result in a sort of rogue process going out there and spawning hundreds of other processes. You call them like fork bombs, or there could be hung processes that never die. So your customer has requests coming in, processes are being spawned for every one of those requests. Those processes finish their task, but then they just hang around there. They don't die. Because of, again, some issue inside in the code or some issue in the system in some form. And so again, we define process limits, saying that on a per user or per shared hosting site basis, there's a fairly large limit in terms of beyond these many processes, a site cannot spawn a process beyond this limit. It's a sizable limit that, again, 100% of the scenarios where anybody would look at a legitimate use case, it would be fulfilled by it. But again, if there's a problem with somebody's code, or if there is any error or bug that's causing excessive process spawning, it'll again get blocked at that point in time. On network, there are, again, several issues. Again, a lot of people who run dedicated servers, you will have probably invariably faced this issue at one point or the other. Most shared hosting companies will always face this. Somebody buys a hosting package on your server and uses it to launch an outbound DDoS attack. It happens to everybody. The first time you set up hosting as an environment, you learn this. There are automated scripts out there that literally do this. They'll go buy hosting packages. If they find that your server is vulnerable, they'll buy hosting packages on your server and use that as a launch pad. And it's an awesome launch pad, right? If you use an individual's desktop, for launching an outbound DDoS attack, you're getting like a few kbps to maybe an mbps of bandwidth, but here you're sitting on like a data center pipe, 100 megs, and shooting out packets. You can launch a pretty large-scale attack with like just 10 such servers or 20 such servers. And so it's very important to prevent these kind of scenarios by limiting the network bandwidth that each hosting site can get, both outbound and inbound in some sense. Mostly outbound, we sort of limit outbound bandwidth, we limit outbound DDoS attack possibilities, we limit outbound spam. That's another common use case for hosting companies where people buy packages and then use that to send millions and millions of emails and spam using your servers. And so again, we detect that and block that by putting in sort of rate limits, etc., for outbound spam. And by default, obviously, this is standard sort of textbook configuration that when you set up a server, you'll block all outbound ports and only when a customer explicitly requires to open a specific outbound port for a specific purpose, they fill in a form with our support team, and we actually make sure that it's a legitimate use case and then open that port so that that server is not vulnerable to being able to sort of launch outbound attacks, etc. Invariably, the biggest challenge always in any hosting environment is going to be your database and your disk IOPS. We do a ton of stuff in, this is an example with MySQL. We do the same thing with MS SQL. But there's so many different issues that are possible in MySQL if you don't apply appropriate resource limits for every one of your customers. They can go out there and set up a MySQL database and, create 10,000 tables. And, that will result in a significant amount of resource bottlenecks for you guys for that particular hosting server. They can spawn too many connections to the database, leak connections where their application is making a connection to the backend database, finishing its work, but then not dropping that connection, just keeping it alive. And they keep spawning newer and newer connections until some point in time you'll see so many connections that have just leaked, which nobody's using, but they're just lying idle out there, without any transactions. There's long-running queries, database queries. RDBMS design is again is an art. It takes time. It takes a knowledge and understanding of sort of database normalization principles, appropriate indexing, etc. And invariably in the hosting environment, you'll find a certain percentage of your customers don't have the wherewithal to architect a database properly. But it's so damn simple to build a LAMP application that you can so many opportunities to screw up that you just build one up and dump it out there. And it'll end up hogging up. And these are tiny applications that are probably not really even fielding too many hits, but just one badly running query on a large table that comprises of gigabytes of data that does a full sequential scan on that table. That query will end up taking, 30, 40, 50, 60 seconds to run, during which time it's going to take the entire data into memory. If it's badly written, it's doing an entire sequential scan, screwing up your, I'm getting a bit technical out here, but screwing up your entire disk buffer cache, because now data that was needed to be in memory is gone and evicted because this useless data that was needed only for one query is now come into memory. Suddenly your entire system will crawl to a halt in terms of speed of responsiveness for everybody else, start thrashing, start swapping, and you'll essentially result in bad service or bad uptime or most cases really lousy responsiveness for your users and customers, right? So long-running queries, unoptimized queries, unindexed tables, bad data model. There's so many ways to screw up database operations. So again, out there, all of this results in excess CPU, disk, and memory consumption. And we have a bunch of, this is actually a subset of it, if I remember correctly. There's a bunch of different limits that we've created, resource limits that we've created for MySQL and for all databases, where we limit the number of tables, limit the number of connections, limit the query runtime. If any query takes greater than a certain amount of time, we'll basically limit that. It won't be able to take more than that threshold. And it becomes automatically a clue to whoever's written that bad application to determine, okay, listen, I got an error, and it's because my query's been running for more than 30, 40 seconds or 15 seconds or whatever it is, and I need to improve that. And invariably, in most circumstances, if a database query is taking longer than a second, then you've got something wrong somewhere in your data model. In fact, ideally, I would say in the order of tens of milliseconds. But that, again, requires sort of effort on the application developer's part, right? So as a shared hosting provider, we have to make sure that the guys who are doing a good job of writing their applications are not penalized because somebody in the system is not necessarily doing the best job in writing their application. So all of these sort of database level limits take care of that. On the email side, we try and make sure that, as I said before, that our hosting servers cannot be used for outbound spam, as well as our hosting servers cannot be used to receive a large amount of inbound email, or somebody can't spam or send a large amount of inbound email to these hosting servers. So there are rate limits, etc., that take care of that, and the number of POP and IMAP connections that we allow on a per IP address or a per website basis, etc., also takes care of some of that. And disk usage, which I think is sort of the last one in the list of resource limits. So there again, there's I/O operations and inodes. Inodes is sort of directly correlated to the number of files. But you'll again find sometimes there are people who buy a hosting package, and the unlimited part again sort of gets in the way, right? So even if you set a high watermark of, let's say, 20 gigs or 10 gigs of disk space, they'll put thousands and thousands or hundreds of thousands of files. I mean, we've seen cases, by the way, where people have put in 250,000, more than 250,000 or more than 300,000 files in a single hosting package. Clear violation of our AUP. They're doing something that's not permitted by our AUP. So there are ways that we detect this stuff, and so there's a hard limit that we set any which ways. People who require to go beyond that hard limit for legitimate reasons, which, by the way, in my entire tenure till now, I haven't found one case of a legitimate reason to go beyond the limit that we've set. But again, this is to make sure that people are not abusing this stuff for hosting, Varese sites or hosting large number of videos or large number of photos, etc., for a purpose that's not legitimate. And then disk IOPS. Disk IOPS is a complex parameter to control a resource limit. So the two philosophies that we follow out there is everything else we have resource limits for, but in case of disk IOPS, the two things that we do is we always have a large pool of available disk IOPS by optimizing the system, using RAM in an interesting way, using SSDs in an interesting way, optimizing the OS disk buffer cache, using battery-backed RAID controller caches, and so on and so forth. So all of this allows us far greater headroom than most standard servers, the way they're pre-configured out of the box, in terms of the number of disk IOPS we can provide. And then at the same time, we also monitor them very, very closely to try and make sure if there's any abuse of disk IO operations taking place from any particular website, that we can sort of, again, limit that within a significantly high enough limit that it can only qualify as abuse. So that's sort of all these stuff. Again, this is, I would say, about 20–30% of what actually is underlying, because each of these in turn break into multiple processes and multiple scripts and multiple programs that perform many different tasks to achieve these limits. But this is sort of a small subset of stuff that we do on each of our hosting servers. The next part is security, and I can, very honestly and candidly state that, again, all these years of running a hosting enterprise and running a hosting company, at least in the early years, I remember we've had sleepless nights on this, but we've gone through situations where our servers were hacked. I remember 6 years ago, there was this time when 3 of our hosting servers, all of the websites were completely defaced in terms of replaced with, the index pages were replaced with defaced content, etc. Every one of us has been through those situations and sleepless nights and learned along the way to sort of figure out, what are the different kinds of vulnerabilities, to a point where now I can say that we've got some of the best security stuff out there on every one of these systems. And again, I have a small sliver of some of the stuff that we do. We use something called ModSec, which inspects all the requests to and fro that come to various websites that are hosted for hundreds of known vulnerabilities, and also sort of by default prevents attacks on your customers' websites. Common attacks like SQL injection attacks or cross-site scripting, XSS attacks, etc. And then, we can also sort of build out a reputation of source IP addresses from where we get requests, and we can configure rules based on, the kind of requests that we receive. So if we're constantly receiving typically, for instance, you'll find vulnerabilities in software like WordPress or Joomla or whatever. Whenever they find vulnerabilities, is based on certain kind of request patterns that result in a vulnerability. And you'll find that the moment a vulnerability becomes known, then there are all these botnets that are constantly doing nothing but scanning through every IP address in the world, trying to make an HTTP request with that vulnerability string pattern to see if your server is vulnerable or somebody else's server is vulnerable. The moment they find a vulnerable server, they basically, there's a hack attempt, and again, it could be something like defacement or deletion, or using that server again as a springboard to launch attacks on other servers, and many different kinds of sort of sophisticated kind of attack vectors. And so, based on known attack patterns, if we detect them, we automatically sort of classify those IP addresses from where we receive those attack vectors and attack patterns, and we can sort of configure rules for them, etc. One of the steps that we've taken, and again, this is not something that everybody in the hosting industry does, but some companies do, that we've taken a strict stance on, is we don't do any FTP, we only do FTPS. Now, we've got a ton of grief also from our clients and resellers about this many times, because it takes a few extra steps for a client or a user to configure FTPS on their client to upload files, as opposed to using plain FTP. But and many times I've seen, I've had sales staff come to me saying, why don't we just, everybody else gives FTP, why don't we give FTP? Why we sort of stuck to FTPS? But the fact is that some of the easiest attacks in the world are largely done because of infected endpoint desktops, right? And the moment somebody's desktop is infected, it's very easy to sniff your FTP password and go ahead and deface your website and use that to launch other attacks, etc. And we've seen, there were fairly widespread attacks of this nature that have taken place on the web. In spite of the fact that there are providers, etc., that really offer FTP, we've taken a very clear stance that from a client's machine to our server, the entire transaction, FTP transaction, has to be fully encrypted. Even though it takes a few extra steps that we've tried to make easy by documenting them for customers, etc. But we've sort of taken that stance on our side. One of the other things that we're deploying soon is something called Cloud Linux on all of our servers, which provides also sort of a far more secure SSH experience, such that each customer's SSH shell access is sort of inside what's called a lightweight container, which is completely isolated from another customer, to a point where then any vulnerability cannot sort of cross that boundary. So anyways, this is some of the stuff that we do from a security standpoint. Then, of course, another big part of actually one of the biggest part of running a good web backend, not just hosting companies, but whether you're running an e-commerce portal or a website or any form, the biggest challenge, the largest amount of effort goes behind metrics and monitoring and alerting and escalations and systems like that, right? And we've spent years and years and years modifying open source tools, configuring them to our needs like NaggyOS, Ganglia, Graphite, OpenTSDB, etc., to a point where we've sort of fully automated this for our entire operations. So for instance, we have an internal tool called Montreux, which again sort of monitors every single shared hosting site that is hit by any of our abuse limits. So all the resource limits that I spoke about, there's a single dashboard that our operations team can see at all points in time. Out of all of our tens of thousands of websites, since it's a small fraction, as I said, less than 1% of the sites actually ever hit those limits, and a very small fraction of them actually get impacted by them in any sense. But this dashboard sort of shows us a bird's eye view of all of the sites that we have, which ones of them are hitting specific limits, etc. And then we can consult those customers and talk with them and explain to them, that there might be something wrong with their configuration or their scripting or their coding or something like that they need to fix to alleviate that concern. I'm going to show you, if I showed you my entire, all the screens and stuff and all these statistics and metrics that we monitor, that would actually consume the entire day and we'd still sort of cover a small sliver of it. There are literally hundreds and hundreds of statistics that we collect on a 5, 10 second or 1 minute interval from every one of our servers. Everything. If you look at CPU, there's like some 20, 30 different statistics, right? From load average, context switches, idle status, percent user, percent. There's so many different stats for memory, for network. So typically, and there's an interesting model, in fact, that's actually also sort of used for monitoring and metrics called the use model. Use stands for utilization, saturation, and errors. And it's sort of a pretty interesting way to sort of look at your statistics, which is that for any resource, so let's say CPU, the three things you want to monitor is utilization, which means how much of it is currently being used, whether it's on a per site basis or per server basis or whatever. The second thing you want to monitor is saturation. Is that resource saturated to a point where customers are going to get disservice? And the third thing you want to monitor is errors, which is that resource throwing any errors whenever it's being accessed or whenever it's being utilized, etc. And so each of these resources, like CPU, disk, etc., have again tens of statistics, which either for utilization or saturation or errors, each of which are monitored across all of our servers. These are some of the interfaces that this I think is a CPU graph of all of our servers ordered by the kind of load that is existing on every one of those servers, etc. So as I said, we collect hundreds of metrics across these resources: CPU, processors, memory, disk, and network, and then basically graph and plot every one of them. And then every one of those metrics has threshold levels, and then those threshold levels trigger our alerting system whenever any server or system sort of hits those threshold levels. This, for instance, is again, I want to just show you examples of various tools. Graphite is a very powerful, outstanding graphing tool. It's an open source free utility. In fact, a lot of our business metrics are also graphed in Graphite. Things like number of clients, number of users, revenue charts, etc. A lot of people in our company use Graphite proliferantly. But it's really amazing, this kind of stuff that you can do with Graphite. You just throw stats at it, and then subsequently you can write formulae to generate any kind of graph that you want. So we have a lot of stuff graphed out there. This, for instance, is an example of a graph of the top 20 or whatever, top X websites by CPU utilization across a certain part of our infrastructure, etc. So there are many such graphs and monitors that we built, again, for hundreds and hundreds of metrics across all of our infrastructure. Lastly, of course, I think this is the last section. We also build a lot of internal support tools. Every now and then, customers send us tons of, we field thousands of support requests on a daily, weekly basis. And we have a special team, which is a support automation team, that actually looks back every week at all the kinds of requests we receive to try and see which of those requests we can automate completely and offer a tool either to our support team or in ideal circumstances, directly to the end customer. I'll show you some of the stuff that's actually being built or has been built and already deployed. I think there are 2 of them that I'm showing you right now in the screenshots. But the goal is to try and, well, one, of course, the selfish motive is to try and reduce support requests and reduce our costs. But what's more important is the more tools and information you provide to your customers, or that we provide to you guys and your customers, the faster the resolution. If a customer can solve a problem himself, he's going to be far more happier than contacting you and then waiting for 20 minutes before a response comes and then figuring out what to do, etc. So we have a constant process and a constant goal across all of our services to try and identify opportunities where we can take a support request and say, okay, look, could we convert this into a feature or a tool such that this request need not exist going forward? So for instance, this is one of our health check tool that we've built, where given any website, this is the typical, and again, you guys will sort of empathize with this with this situation. In the last 12 years of again running a hosting business, one of the worst issues that we face in support is that a support request 80% of the time contains, fortunately we deal with resellers, so sort of its advantages, but when you deal with end customers, says, my website is not working, and that's pretty much it. And you really don't know what does he mean by my website is not working. It could actually be his email misconfigured. It could be his internet connection that's not working for crying out loud. But literally, that's what the ticket says. My website is not working. Here's my domain name. Fix it. And so then we have to run through the motions and perform all these checks. And there's so many things: MX records, A records, DNS, net connectivity between the user and us, database connectivity, Apache, MySQL. There's so many different variables. And so what we're doing is we built out this sort of automated testing tool where we put in a website and it runs all those checks one by one by one. We're giving sort of a status that this check passed, this check passed. So in sort of matter of minutes, you get an exact idea in terms of, for this website, this is the health check that failed, and so you exactly know what to troubleshoot. And we'll be making this tool, I believe it's not currently available, we'll be making this tool available to customers also. This is one such example. Same, the health check tool, sort of the continuation of that. This is, for instance, an inode monitor. I was talking about it earlier, right? Where in any given website, people might abuse it by putting in hundreds of thousands of files, and they're somewhere inside some folder. And if you need to delete them or move them or copy them somewhere, etc., and give the customer a warning and things like that, it becomes difficult to sort of find out where those files are. So we've got tools that sort of allow us to do that, which will scan the entire folder tree and figure out exactly where the problem is and highlight that so that we can sort of go out there. So there are many, many such tools that our support team directly themselves, some of them sort of self-converted to programmers over time while sort of working in support, and along with sort of assistance from our DevOps team and our system administration team. There are many tools that these people build out on a constant basis that will actually make their lives easier, and then over time make lives of our sort of customers easier. And that's sort of all the intelligence, or subset of the intelligence that I want to share with you guys to give you an idea of sort of what goes on in the back end when we're running sort of a large-scale hosting infrastructure. So thank you.